Thank you, Steve. It's great to have the opportunity to talk to you about some of the research we've been doing based on this fantastic imaging resource obtained in UK Biobank. And our research is particularly focused on the DEXA scans. We heard from Tonya that the DEXA scan produced these images at a number of different sites, particularly of I've got here, there's the hip, the spine, the knee, and then a sideways view of the spine. And so, as well as numbers that come out, like bone density measurements that we can use to diagnose osteoporosis, there are all these images that are produced. And our research is designed to try to extract information from these images that can tell us about musculoskeletal disease. Now, you might well have heard about use of DEXA scans in diagnosing osteoporosis. This is a condition where there's an increase in fragility of the bone, leading to fractures as a consequence of reduced bone density. And this, for example, underlies about 75,000 hip fractures a year in the UK. And traditionally, hip DEXA scans and spine DEXA scans are carried out if, for example, you're referred to have a DEXA scan in hospital to look at possible osteoporosis. Well, we're also interested in osteoarthritis, which is kind of sort of a wear and tear of the joints. And when we're talking about kind of big joints, we're talking about hip and knee joints. So, for example, underlying 85,000 hip replacements a year in the UK and 100,000 knee replacements. So it's a common condition. And some of the things that we can pick up on X-rays, for example, hip, I've got here, that you can see what are called osteophytes, which are a little outgrowths of bone at the edge of the joint. And you can also see the space between here, the hip and the pelvis, where the joint space is supposed to be. That gets worn away, so the joint space gets reduced, reflecting the loss of cartilage. So as part of the Augment study, which is a project that we're leading from Bristol, funded by the Wellcome Trust, and it's bringing together a number of different institutions in the UK, where we're kind of trying to use these the DEXA images from UK Biobank to look more closely at the relationship between osteoarthritis and joint shape based on the DEXA images obtained from the imaging study. So you can understand that we're thousands and thousands of images, much larger, as we've heard, than anything that's been undertaken anywhere else, like sort of 80,000 currently. And in order to deal with those kind of numbers of images, you really have to be able to automate any kind of analysis. So we teamed up with universities of Manchester and Aberdeen, who have got the experts in image analysis. And so if you're looking at on the left, that's the DEXA image of a hip, but then we get this software can sort of automatically detect the edges of the bone and put these dots, these around the surfaces of the bone, and then also recognize where these outgrowths of bone are, these osteophytes that are not actually the bone, part of the main anatomically joint itself, but these outgrowths of bone, we can recognize those, and then we're color coding them and working out how big they are. And this has got to be done in an automated way to be able to deal with this huge scale of the images that were being obtained. And so we've linked this information that we've generated to other information obtained in UK Biobank to find some really interesting relationships between shape and musculoskeletal disease. So, for example, we've compared joint shape in those UK Biobank participants according to whether they do or do not undergo a hip replacement. And as you can see in green, that shows the shape of individuals in UK Biobank who subsequently have a hip replacement, compared with those who do not, shown in black. And you can see I've got a couple of arrows there. The arrow at the top shows that in UK Biobank participants who subsequently undergo any replacement, the green, the top of the pelvis above the head of the hip is pushed back a bit. And that might mean that there's a condition called acetabular dysplasia, where the cup that the hip sits in might be not quite properly formed sort of early on in life, and it might be that this is a sort of predisposition to getting a hip replacement. And then what was also interesting, you can see that this is outgrowth of bone. The lower arrow in those who have a hip replacement, and it possibly suggests that people who have a hip replacement, as well as wearing out of the joint itself, the bone around it might also become a bit abnormal and start to go out a bit like not only do you get these outgrowths of bone called osteophytes, but it seems like the stem, the femoral neck, as it's called, just below the head, also start to expand as part of this abnormal bone growth process happening in osteoarthritis. So we've seen one or two other changes, as well as looking at shape. We can derive various measurements like width of the femoral neck, diameter of the femoral head, this other thing called hip axis length. We can measure these from the points that we've placed and compare those according to whether, for example, people have hip replacements. And then we can also so we've also taken this opportunity to compare shape, in this case, white UK Biobank participants as a sort of an ethnic study to people from China. We teamed up with a cohort called the SC cohort in China, and we just simply compared their hip shape. And it's known that for some reason, Chinese people often have a lower risk of hip replacement, and we were wondering whether of osteoarthritis generally of the hip, and we wondered if this could be explained by alterations in hip shape. So we basically just here comparing hip shape in UK Biobank participants to those in China, just to look at potential ethnic differences that would also contribute to ethnic differences in risk of having osteoarthritis. I've talked up until now about sort of shape changes in those with hip replacements, but looking at people with kind of earlier on, more mild osteoarthritis, what about people just with a bit of hip pain? Well, we found that we can actually, these osteophytes that we're detecting with DEXA scanners using this method we've developed, actually showed a very strong relationship with risk of having hip pain, suggesting that these osteophytes that we're able to pick up on these DEXA scans might actually be giving us a strong signal, if you like, in terms of picking up people at risk of having hip osteoarthritis. So although hip DEXA scans are traditionally used to pick up people with early osteoporosis that might need treatment to make their bones stronger, well, maybe we can use these same methods to pick up people who have who are early on in terms of risk of osteoarthritis. And as you might be aware, the great thing about DEXA scans is, although they're X-ray based, they use a very tiny dose of X-rays, which means that they can be used to kind of screen, if you like, very low risk populations. So unlike X-rays, you know, your doctor would only arrange for you to have an X-ray if they thought actually there might be something wrong with it. Actually, we can use DEXA scans to screen lots of people. And although as well as screening people for osteoporosis, well, maybe we can be screening people to see if they have osteophytes and risk of osteoarthritis. So the other thing we've done is we've related some of these shape measures to the genetic information. As you know, there's some detailed genetic information that's been obtained in UK Biobank participants, and this can be a very powerful tool for understanding genetic influences on disease, and not only as a way of finding people who might be at risk of getting genetic problem, might be at risk of getting osteoarthritis by doing a genetic test, but also as a way of finding genetic signals in terms of, that might be useful for in terms of drug discoveries. So, for example, the light brown signals at the bottom here seem to be genetic signals that can maybe protect against osteoarthritis by increasing cartilage thickness. Then finally, just to make the point that we've also applied the same methodology looking at knee shape. And we've linked knee shape to people who are getting knee replacements, and finding that, sure enough, we're getting these expected shape changes in people at risk of having who go on to get knee replacements, seeing this kind of bow-legged appearance that we're picking up on the knee DEXA scans. And in addition, we're finding that we can pick up knee osteophytes on these knee DEXA scans, and they're also likewise related to getting risk of having knee pain. So just to conclude, hip and knee DEXA scans, the aim is to get these obtained in nearly 100,000 participants in UK Biobank as part of the imaging enhancement study. As part of the augment study, we've derived several measures of joint shape and features of osteoarthritis from these scans. Understanding the relationships between joint shape, osteoarthritis, and other influences measured in UK Biobank, like genetic factors, may help us to understand the causes of osteoarthritis and to possibly identify new potential targets for developing new treatments. And our findings also point the way to using DEXA scans to screen for osteoarthritis as well as osteoporosis. Okay, thank you.